Hello everyone. So today we will be covering what is AWS DMS, which is nothing but database migration service tool provided by Amazon to migrate your on-premise databases to Amazon cloud. So before proceeding, please do subscribe my channel to stay updated with the latest trends, and also please do like and share my video if you find it worthy enough. This would be basically a theoretical session and a bit of practical where I will be showing you each and every point where what all things these are, and in my next session I will be showing you how we can migrate our Oracle database, on-premise Oracle database, to Amazon RDS Oracle. So what all things we will be covering in here is, as you can see, what is AWS DMS, the advantages of it, how AWS DMS works, the components of AWS DMS, in during maintenance window, what all things you need to take care of, the endpoint source and target endpoints, and the limitations of it. So what is AWS DMS? It is a data migration service, and it is a tool, and it is a cloud service that makes it easy to migrate relational databases, data warehouses, NoSQL databases, and other types of data stores. You can use AWS DMS to migrate your data into the AWS cloud between on-premise instances through an AWS cloud setup, or between combinations of cloud and on-premises setups. With AWS DMS, you can perform one-time migrations, and you can replicate ongoing changes to keep your target source and targets in sync. We will be covering it as we go ahead with our session. If you want to change database engines, you can use the AWS schema conversion tool to translate your database schema to the new platform. You can use this AWS DMS to migrate the data. So what does this mean? It means if you are migrating cross-platform migration, if you are doing a cross-platform migration from, let's say, from Oracle to Aurora DB, or Oracle to PostgreSQL, or PostgreSQL to Oracle, that time you need this AWS schema conversion tool to translate your database schema to the new platform. AWS DMS is a web service that you can use to migrate data from a source data store to a target data store. These two data stores are called endpoints. You can migrate between source and target endpoints that use the same database engine, such as from an Oracle database to an Oracle database. You can also migrate between source and target endpoints that use different engines, such as from Oracle database to a Postgre database. The only requirement to use AWS DMS is that one of your endpoints must be an AWS service. You cannot use AWS DMS to migrate from an on-premise database to another on-premise database or any other cloud. It should be one of the endpoints should be your AWS service. So how does AWS DMS works? AWS DMS is a server in the AWS cloud that runs replication software. You create a source and target connection to tell AWS where to extract from and load to. To start a migration project, identify your source and target data stores. These data stores can reside on any of the database engines. For both the source and the target, configure endpoints within AWS DMS like source endpoint and target endpoint that specify the connection information to the database. The endpoints use the appropriate ODBC drivers to communicate with the source and target. So AWS DMS is clever enough to identify the ODBC driver which they need to use. Provision a replication instance, which is a server that AWS DMS automatically configures with a replication software. Create a replication task which specifies the actual data tables to migrate and data transformation rules to apply. AWS DMS manages running the replication task and provides you the status of migration process. So this is the source database. From here, we need to configure the source endpoint, the replication task, the target endpoint. First of all, we need to configure the replication task, then the source and target endpoints, then the database migration task we need to configure to proceed. To perform a database migration, AWS DMS connects to the source data store, reads the source data, and formats the data for consumption by the target data store. It then loads the data into the target data store. Most of this processing happens in memory. Though large transactions might require some buffering to disk, cached transactions and log files are also written to disk. So most of the things it is done in memory. But if you have lots of data to be migrated, means your database size is huge, then at that time you may need some extra disk for buffering purpose. At a high level, when AWS DMS, even using AWS DMS, you need to do the following. You need to create the the replication server. Then you need to create the target and source endpoints that have connection information about your data stores. You need to test the connections so that you are sure that the connections work properly. Then create one or more migration tasks to migrate data between the source and the target. A task consists of three major phases: full load of existing data, application of cache changes, and ongoing replication. So during a full load migration where existing data from the source is moved to the target, AWS DMS loads the data from the tables on source database data store to tables on target data store. While the full load is in progress, any changes made to the tables, you need to remember, any changes made to the tables being loaded are cached on the replication server. So if you go by this, any changes made to the table are cached on the replication server. And this replication server is nothing but an EC2 instance. And these are the cached changes. It's important to note that AWS DMS does not capture changes for a given table until the full load for that table is started. When the full load for a given table is complete, cached changes for that table are applied. When all the tables have been loaded, it begins to collect changes as transaction for the ongoing replication phase. AWS DMS also creates the target schema objects necessary to perform the migration. It creates only those objects required to efficiently migrate the data. But you need to remember, for migration of an Oracle database, you need to create the target schema on your own. AWS DMS does not create the target schema. So what are the components of AWS DMS? As I told earlier, replication instance, which is nothing but an EC2 instance running on behind. Endpoints, which are the source and target endpoints. Replication tasks, which is migration task. So what is replication instance? At a high level, it is simply a managed Amazon EC2 instance that hosts one or more replication tasks, as I told you earlier. A simple replication instance can host one or more replication tasks depending on the characteristics of your migration and the capacity of the replication server. When you create an AWS replication instance, AWS DMS creates a replication instance on an EC2 instance in an Amazon VPC. You use this replication instance to perform database migration. The replication instance provides high availability and failover support using a multi-AZ deployment. When you select the multi-AZ option, AWS DMS also uses a replication instance to connect to your data store, read the source data, and format the data for consumption by the target store. It also loads the data into target data store. So most of this processing happens in memory. However, large transactions might require some buffering on disk. Cached transactions and log files are also written on disk. So this is the replication. Whether your database is small or whether it is a large database you are migrating, likewise you need to check which replication instance type you need to for your migration. So each replication instance has a specific configuration of memory and virtual CPUs. To help you determine which replication instance would work best for your migration, you need to check this. And so let us assume that you are running a full load CDC task. In this case, the task has its own SQLite repository to store metadata and other informations. Before AWS DMS starts a full load, these steps occurs. It starts capturing changes for the tables it's migrating for the source engine's transaction log, as I told you earlier. We call these as cached changes. After full load is done, these cached changes are collected and applied on the target. Depending on the volume of the cache changes, these changes can directly be applied from the memory, where they are collected first up to a set threshold. Alternatively, they can be applied from disk if your data volume is much high, and where changes are written and where they can be held in memory. And after the changes are applied, by default AWS DMS starts transaction and apply on the target. And during the apply cache changes phase and ongoing replication phase, AWS DMS uses two stream buffers, one each for incoming and outgoing data. AWS DMS also uses an important component called a sorter, which is another memory buffer, and it tracks all transactions and makes sure that it forwards only relevant transactions to the outgoing buffer. It also makes sure that the transactions are forwarded in the same commit order as on the source. So let us log into our AWS console and see the basic features of how to create a replication instance. Here we are in our AWS console. From here you need to go to your migration assistant. Migration and transfer. In here we have our database migration service, DMS. In here, first and foremost thing what you need to do is you need to create an AWS replication instance. I have already created it, but to show you how to create it, you need to go to this. You need to give the name, the description, in which class you need, the engine version. Let's take the default one. Allocated storage, let's take it as default. The chosen VPC, we can take it default VPC. If you need it in multi-AZ, you need to click this option. For publicly accessible, this maintenance window and a tag. So already I have one of them created. Let us go ahead with this. Let us see this. So in here, if you see, this is already created and the status is shown as available. The VPC, which is given in here, VPC security group is given as SG security group this, and the replication subnet is this. Choose the Amazon VPC you want to use. If your source or target database is in a VPC, choose that VPC. If your source and target are in different VPC, ensure that they are both in public subnets and are both publicly accessible. And then choose the VPC where the replication instance is to be located. And for availability zone, choose the availability zone where your source database is located. The KMS master key, you need to choose the encryption key to use to encrypt the replication storage and connection information. If you choose default AWS DMS, the default AWS KMS key associated with your AWS and AWS region is used. You can delete your replication task from here, replication instance from here, but this time it will be deleted because you don't have any database migration task created. If you have any database migration task created, then that use this replication instance, then you must stop and delete the task before deleting the replication instance. Next, let's proceed with our endpoints. An endpoint provides connection, data store type, and location information about your data store. AWS DMS service uses this information to connect to a data store and migrate data from a source endpoint to a target endpoint. You can specify additional connection attributes for an endpoint by using extra connection attributes. These attributes can control login, file size, and other parameters. AWS DMS uses an endpoint to access your source and or target data store. The specific connection information is different depending on your data store, but in general you supply the following information like endpoint type, which can be source or target, the engine type depending on the database engine, let it be Oracle, PostgreSQL, or your DynamoDB or your MySQL. The server name you need to provide either the server name or the IP address where the DMS can reach, the port number like the TNS endpoints, the encryption, the SSL mode if SSL is used to encrypt the connection, the credentials, username and password for an account with the required access rights. So when you create an endpoint, you use AWS DMS console. Using AWS DMS console, the console requires that you test the endpoint connection. I will be showing you. If the connection test is successful, AWS DMS downloads and stores schema information to use later during task configuration. Schema information might include table definitions, primary key definitions, and unique key definitions. More than one replication task can use a single endpoint. For example, if you might have two logically distinct applications hosted on the same source database that you want to migrate separately. In this case, you create two replication tasks, one for each set of application tables. You can use the same AWS DMS endpoint in both tasks. You can also customize the behavior of an endpoint by using extra connection attributes, which can control various behaviors such as login detail, file size, and other parameters. So let us log into our AWS console and see how we can configure our endpoints and how we can test it. So here we are in our AWS console, and let us go to our endpoints. We already have the source and target endpoints. I have already created it. How you need to create is create an endpoint, source, target, and if your source is an RDS DB instance, you need to create it, see in here, and then create it. Then endpoint identifier, source engine, endpoint specific connection attributes, KMS master key, tags, and test. I will show you in here. As you can see, the status is active, SSL mode is none. Server name, I have given the server name in here. This is from my EC2 database. My database is located in EC2. Endpoint engine is Oracle. Endpoint source type is source, and the port it is using 1521. The database name is this. Username is this. Then the connections. You can see the connection is successful. If I run right now, the connection will be failing because my database is stopped in there. The schemas, there are no schemas in this endpoint currently mentioned, and tags, if you want to mention, you can mention the tags. Likewise, for your target endpoint also, you can see the endpoint is Oracle. This is my RDS endpoint, my username, the port, the database name, the KMS key, and you can see that connection in here is also successful. I will show you how we can go ahead and create the connection these endpoints in my next session, because Simply just creating the endpoint from here won't be created, won't make your connection tests as successful, because you need to provide many privileges to make so that your DMS user can connect with your source or target databases. You need to give some privileges, and after you give those privileges, then only the connection would be successful. So the next phase is replication task you need, or the database migration task you need to create, and you use this replication task to move a set of data from the source endpoint to the target endpoint. Creating a replication task is the last step you need to take before you start a migration, and this task is where all the work happens. You specify what tables or views and schemas to use for your migration, and any special processing such as login requirements, control table data, and error handling. When creating a migration task, you need to know several things. Before you can create a task, make sure that you create source and target endpoint as I showed you earlier. Currently, I have my replication instance and my source and target endpoints being created. You can specify many task settings to tailor your migration. You can set these by using AWS Management Console, AWS CLI, or DMS API. These settings include specifying how migration errors are handled, error logging, and control table information. After you create a task, you can run it immediately. The target tables with the necessary metadata definitions are automatically created and loaded, and you can specify ongoing replication. By default, AWS DMS starts your task as soon as you create it. However, in some situations, you might want to postpone the start of the task. For example, when using the AWS CLI, you might have a process that creates a task and a different process that starts the task based on some triggering event. As needed, you can postpone your task start. You can monitor, stop, or restart tasks using the console, AWS CLI, or DMS API. So in the replication task settings, when you create a replication task, you specify the following task settings: the replication instance, the source endpoint, the target endpoint, and the migration type options. We will be going through all these in our next session, which will be a totally practical session. So before you go ahead, you should know what all things you need to, you should be theoretically aware of it before you go ahead with the practical. That's why this I'm taking this session, this theoretical session. And the migration type options, as listed, they can be full load, means migrating the existing data. So if you can afford an outage long enough to copy your existing data, this option is a good one to choose. This option simply migrates the data from your source database to your target database, creating tables when necessary. Then comes another option, which is full load plus CDC, means migrating the existing data and replicate ongoing changes, which we are talking about. And in this option, it performs a full data load while capturing changes on the source. After the full load is complete, captured changes are applied on the target. Eventually, the application of changes reaches a steady state. At this point, you can shut down your application, let the remaining changes flow through the target, and then restart your application pointing at the target. Then CDC only, which will just replicate the data changes. And in a homogeneous migration, using native export and import tools might be more efficient at loading bulk changes, bulk data. In this situation, you can use AWS DMS to replicate changes starting when you start your bulk load, to bring and keep your source and target databases in sync. The target table preparation mode options are listed as follows: do nothing. AWS DMS assumes that the target tables and are pre-created on the target. Drop tables on the target. In here, AWS DMS drops and recreates the tables. Truncate: if you create tables on the target, AWS DMS truncates them before the migration starts. If no tables exist and you select this option, AWS DMS creates any missing tables. LOB mode options do not include the LOB columns, as the name suggests. Full LOB mode, and this mode is slower than using the limited mode. Here migrate complete LOBs regardless of size, and the DMS migrates LOBs piecewise in chunks controlled by max blob size parameter. And in limited blob mode, truncate LOBs to the value specified by the max LOB size parameter. This mode is faster than using full LOB mode. Table mappings, it indicates that the tables to migrate and how they are migrated from this table, from A table to table A, or from table A to table B. Data transformations, changing schema, table and column names, changing table space names, or defining primary keys and unique indexes, data validation, and CloudWatch login. These settings you need to provide. So the effects of maintenance on existing migration tasks. When an AWS migration task is running on an instance and if any patch is applied, what happens? If the tables in the migration task are in the replicating ongoing changes phase, AWS DMS pauses the task for a moment while the patch is applied. The migration then continues from where it was interrupted when the patch was applied. Or if the AWS DMS is migrating a table when the patch is applied, it restarts the migration for the table. Schema and code migration, it does not support schema or code conversion. You can use tools such as Oracle SQL Developer, MySQL Workbench to move your schema if your source and target are the same database engine. If you want to convert an existing schema to a different database engine, you need to use schema conversion tool. It can create a target schema and also generate create an entire schema with tables, index, views, and so on. So whenever possible, DMS attempts to create the target schema for you. Sometimes AWS DMS cannot create the schema. For example, as I told earlier, it cannot create a target Oracle schema for security reasons. For MySQL database targets, you can use extra connection attributes to have the DMS migrate all objects to the specified database and schema. Or you can use these attributes to have DMS create each database and schema for you as it finds the schema on the source. The sources of AWS DMS. As I told earlier, the source endpoints. Here, the sources can be of many types. On-premise and EC2 instances, which can be of from Oracle 10.2 to 19c, any version, which can be of enterprise, standard 1, and other two editions. Microsoft SQL Server 2005, 2008, 2012, 14, 16, 17, and 19. MySQL versions 5.5, 5.6, and 5.7. MariaDB versions from 10.0, 10.0.24 to 10.0.28. Postgre from 9.4 to 12.x. MongoDB from 3.x to current versions. SAP, IBM DB2 for Linux, Unix, and Windows. Likewise, Microsoft Azure, we have your Azure SQL DB. Then Amazon RDS instances like Aurora DB and others. And in the targets, you can also use the same as mentioned in our in the source, like on-premise databases or EC2 instances or Amazon RDS instances, Redshift, DynamoDB, Elasticsearch Service, Kinesis data streams, Kafka, Neptune, DocumentDB. The DDL statements which are supported by AWS, you can execute DDL statements on the source database during the migration process. These statements are replicated to the target database by the replication server. You can see that DDL statements which are supported by DMS, which are create table, drop, rename table, add column, drop column, rename column, and column. You can also change the column data type. There's limitation of AWS. The maximum size of the database that can migrate depends on your source environment. The distribution of data in your source database and how busy your system is. The best way to determine whether your particular system is a candidate for AWS DMS is to test it out. Start slowly so you can get the configuration worked out, then add some complex objects and finally attempt a full load as a test. Each AWS account has limits per AWS region on the number of AWS DMS resources that can be created. So once a limit for a resource has been reached, additional calls to create that resource will fail with an exception. Here is the limitation of AWS DMS. The replication instances default limit is 60. The total amount of storage for the replication instance is 30,000 GB. This 30,000 GB limit is for storage applies to an AWS replication instance, which is used to cache changes if the target cannot keep up with the source, and also for storage storing log information. The storage size of source and target endpoints can extend this 30,000 GB. You can see the event subscription, and these are the limits of AWS DMS. And AWS DMS does not, when you are using an Oracle as a target, it does not create schema on the target Oracle database. It does not support direct path full load option for tables with index type context. And as a workaround, you can use array load. With the batch optimized apply option, loading into the net changes table uses a direct path, which does not support XML type. As a workaround, you can use transactional apply mode. Empty strings migrated from source database can be treated differently by that Oracle target. This can result in AWS DMS validation reporting a mismatch. So what are the advantages of it? AWS DMS takes over many of the difficult or tedious tasks involved in a migration project. So you need to just configure it and leave it to AWS so that they can migrate the data on their own. AWS DMS automatically manages the deployment, management, and monitoring of all hardware and software needed for your migration. Your migration can be up and running within minutes of starting the AWS DMS configuration process. With AWS DMS, you can scale up or scale down your migration resources as needed to match your actual workload. AWS DMS uses a pay-as-you-go model. You only pay for DMS resources while you use them. It automatically manages all of the infrastructure that supports your migration server, including hardware and software patching, and error reporting. It provides automatic failover. If your primary replication server fails for any reason, a backup replication server can take over with little or no interruption of service. It supports nearly all of the DBMS engines such as Oracle, Microsoft SQL Server, MySQL, MariaDB, Postgre, DB2, Amazon Aurora, MongoDB, SAP, anything. You can migrate from any of the supported data sources to any of the supported data targets. AWS DMS supports fully heterogeneous data migrations between the supported engines. It also ensures that your data migration is secure. Data at rest is encrypted with AWS Key Management Service, which is KMS encryption. During migration, you can use SSL, secure socket layers, to encrypt your in-flight data as it travels from source to target. So that is all about AWS DMS theoretical explanation, which you need to know before you proceed with your migration service, because you need to know the each and every points, each and every options which are present before you migrate, so that you are aware of it and you can go ahead with your migration. So if you like my video, please do share, subscribe, and stay tuned to get the practical hands-on on how to migrate an Oracle on-premise database to your AWS RDS. Thanks a lot for watching the video. Take care. Bye.